Welcome to May 5th LeetCode Challenge. Implement stack using queues. Implement a last in, first out LIFO stack using only two queues. The implemented stack should support all functions of a normal stack: push, top, pop, and empty. Implement myStack class. You have the push method function, which pushes the element X on top of the stack. You have the pop function, which removes an element on top of the stack and returns it. A top function, which returns the element on top of the stack. An empty function, which returns true if the stack is empty, false otherwise. Note you may only use standard operations of a queue, which means that only push to back, peek and pop from the front, size, and is empty operations are valid. Depending on your language, queues may not be supported natively. You may simulate a queue using a list or a double-ended queue, as long as you use only a queue standard operation. Alright, we're going to use this to our advantage here, a double-ended queue later, but let's go through the example here. You call the class myStack. You call the first one is push, and what do you want to push? You want to push 1 onto the stack, right? And then the output is null because you don't do it. You push 2 onto the stack as well, and then you want to find the top. The top, if you push 2 onto it, the last number will be the top of the stack will be 2. You pop it, remove the top element of the stack and return it, and then you empty, then just false because it still has 1 inside it, right? And the constraints are between axis between numbers between 1 to 9, and most 100 calls will be made to push, pop, top, and empty. All calls to pop and top are valid. So yeah, basically a stack is how I like to think of it as a stack of plates. Every time you want to add something to the plate, to the stack, you put it on top of the stack, right? And then every time you want to remove something, you take it from the top. So we're going to utilize our double-ended queue here as a built-in native function, I guess, kind of using it cheatingly for the stack using a queue, but hey, we're allowed to do it, so let's do it. So self.queue will be called double-ended queue, and that's going to be initializing our end function. So in order to push onto our stack, we're going to invoke the self.queue.append method of X. So we're kind of relying on a double-ended queue to make a stack, essentially. And then we want to push. So a double-ended queue, we have to push it from basically the left side. So in order to do that, we need to iterate through for each element I in the range of our queue of self.queue -1 because we don't want 0 to be included. What we want to do is basically add each element to the left of the queue, right? And since we have a double-ended queue, in order to add an element to the left, we need to do self.queue.append, and we want to append the left element of the queue, so it'll be pop.left. Okay, pop left, I should say. And that should work. Next thing we want to do is pop an element. We want to pop an element. In order to pop an element, we need to remove the top element and return it, right? So we basically return self.queue.popleft. Pop left, I should say, not pop.left. Alright, top. Top is the element that returns the top of the stack. So we don't want to return it. We just basically, actually, we do return it. Never mind, what am I doing? So return.self.queue, and we want to return the top of the stack, which is the 0th element of the double-ended queue. And then empty, we want to check if it's empty. So in order to return if it's empty, we want to check if size of the length of the self.queue is equal to 0. So that pretty much keeps it all simple and standard. And let's run the code a bit and see how it goes. Alright, submit. Ta-da! There you go. So this is basically using a double-ended queue to kind of implement a stack using a queue, right? And that's pretty much it. We're lucky with Python that it does have some native queue like structures in there that we could use, such as Lisp or double-ended queue. But can you put it using one queue? I mean, I think that's what we just did, right? All right, that is it. Have yourself a great day, guys.